Hey everyone, welcome back to the SakuraDev channel, and this is going to be a new course in my channel, and it is going to be about the GraphQL in NestJS. So I'm going to deliver this course in 3 episodes. In this video, which is going to be the first episode, we're going to dive deep into the fundamentals of the GraphQL in NestJS. We're going to talk about what is the GraphQL and how does it work, and then we are going to set up the GraphQL in NestJS. We're going to talk about the resolvers. I'm going to show you how you can create simple queries as well as the complex ones, and then we're going to go over to the mutations and show you how you can mutate your data with the GraphQL mutations. We're going to talk about how we can resolve the nested objects in GraphQL, and then I'm going to show you how you can enhance your error handling with exception filters in NestJS with GraphQL, and then we are going to talk about the input types and how we can enforce the data validation in GraphQL. And finally, in this video, we are going to talk about how we can handle enums in GraphQL with NestJS. And in the next episode of this video, we're going to cover the authentication and authorization in GraphQL with NestJS. And then in the episode 3 of this course, we are going to cover the advanced TypeScript tricks in GraphQL. And then we're going to go over the testing. And finally, we're going to talk about how we can create paginated queries. And finally, we have a bonus video, which is going to be a very long video in which I'm going to clown a full stack blog project with NestJS in the backend and Next.js in the front end, and using GraphQL as a glue between the Next.js and NestJS. So this is going to be all the topics that we are going to cover in this course. And yeah, I think it's enough with the introduction. And now we can start this course and go to the first section of this video. But before starting, I will be very happy if you like this video and subscribe to my channel for the upcoming content that I've just mentioned. Alright, so let's go to the first section of this video in which we are going to talk about what is the GraphQL in the first place. Well, let's start with the basics. The GraphQL is a query language for your API, and it's been developed by Facebook in 2012, and it was open sourced in 2015. And unlike the traditional REST APIs, GraphQL actually allows the client to request exactly the data they need and nothing more. And this flexibility is what makes it so powerful. Alright, so how does it differ from the REST APIs? Well, in a typical REST API, you might have multiple endpoints like /users, /ID of the user, and /posts. Each of these endpoints returns a fixed data structure, and if you need multiple types of data, you often have to make multiple requests. GraphQL, on the other hand, has a single endpoint, /GraphQL. With a single request, you can fetch related data by defining exactly what fields you want, all in a single query. I'm going to show you how you can create such a queries in NestJS with GraphQL in the upcoming section of this video. But for now, let's talk about how GraphQL actually works. So now that we know what GraphQL is, let's dive into how it works behind the scenes. Actually understanding its architecture will help you see why it's such a game changer in API design. GraphQL has 3 main components that make it work: schema, resolvers, and queries and mutations. So what is this schema? This schema is actually the heart of the GraphQL, and it defines the structure of the data that your API can return and the operation that client can perform. For example, if you're building a blog API, your schema might look like this. You're going to have a user type, and these are going to be the fields of the user: ID, name, and posts. We are going to define type of each field. Some of them, like ID and name, might have a scalar type, meaning a simple type like string, an ID, or a number, but some of them, like post here, is a list of post objects. So here we have a definition of each individual post here. It has an ID, title, content, and this is going to be author of the post object, which here again is not a scalar, which is of type user that we have defined earlier. And here, as you can see, we have a type query, and inside this type, we are going to define our queries. So we're going to have a user query. It takes an ID, which is going to be ID of the user, and it returns an object of type user. Then we are going to have another query, which its name here is post, and it returns a list of posts here. So here, it's kind of similar to the TypeScript, but here, for example, we have some differences. If we are going to define list of a post, we just put the post type inside the square brackets. But in the TypeScript, as you know, we just put the square brackets here after the type name. So this is the way that we define types in the GraphQL schema. In NestJS, in order to write this schema file, we have two approaches, the schema first and the code first. So with the schema first, we need to write the GraphQL schema by ourselves, and we need to write all types in GraphQL language. But we have another approach, which is going to be code first, in which we are going to just write our entity classes in TypeScript, and then we need to mark them with some decorators that the NestJS/GraphQL provides for us, and then the GraphQL module of the NestJS will automatically create the schema based on the TypeScript classes that we write in our code base. I think this approach is more straightforward. So let's back into the components of the GraphQL. We just talk about the schemas, and the next component of the GraphQL is the queries and mutations. So once you have a schema, your clients can interact with your API using queries to fetch the data or mutation to modify data. Here's an example of a query, which its name is user. It takes an ID as an argument, and then the client select the name of the user from the returning user object, and from its post, it just select the title of the post. And this is going to be the result of this query. We have a data object, inside we have a user object, and then it has a name inside it, and then we have a list of posts of that specific user, and each post only has a title inside it. That's because here we just select the title of the post, nothing more. And let me show you an example of a mutation that creates a new post. We just use a mutation keyword here and then call the name of the mutation, which in this case is create post. It takes an input object. Inside it, we put the title of the new post and also the content of the new post. And then from the returning object, which is going to be the post that created inside our database, we just return ID and the title. And the result that client gets from running this mutation would be something like this. We have a data object again, and inside it we have the create post object, which is the same as the name of the mutation. And then inside it, we have the returning object from our database. It is going to be a new post from our database. It has its ID and the title, because here we just select the ID and the title. But as you can see, we have a content here, but here in the returning object, the client decided to not select the content here. So we don't have the content here in the result. So now let's talk about the resolvers. So resolvers are actually the functions that fulfill these queries and mutations. They act as a glue between your GraphQL schema and your data sources like databases or other APIs. So this is going to be a simple resolver in NestJS. I will talk about every details about the resolvers in the upcoming section of this video, but here this is going to be a simple example. We just have a class. Inside it, we're going to have a query, and its name is user. It takes an ID argument, and then it returns an user object, and inside this function actually will resolve this query and return the user service that find by ID function, which actually fetches the user based on the ID that we provide here in the parameters from our database and return it back to the client. All right, we're almost done with the introduction. But before moving into the code section in NestJS, let me show you a diagram that actually shows the request response cycle of the GraphQL. So let me close this document section, and here the query is sent to a single endpoint like /GraphQL. Then the GraphQL validates the query against the schema to ensure it's requesting valid data. Then the query is broken down into individual fields, and each field is resolved by its respective resolver and actually returns field data from our database. Then the resolved data is collected and sent back to the client as a single response. So this is the whole request response cycle. But why this approach is so powerful? Actually, this process gives you the flexibility and efficiency, and clients get exactly what they need, no more, no less. And you as a developer have full control over how the data is fetched and structured. So yeah, that's it for the introduction section. And with this introduction in mind, let's go to the next section of this video, in which we are going to actually implement the GraphQL in a NestJS project. So if you're ready, let's get into the code. All right, guys, so I put up the VS Code, and here as you can see, we have a NestJS application, and I have already integrated the type program and config module module with this application. So as you can see, we have 4 entities in this application. And let me get back to the browser and go to our diagram tool. So here, as you can see, we have the database diagram that we are going to use throughout this application. This is going to be a very simple database for a blog app. So here, as you can see, we have a user model and also we have a profile model. It actually has a one-to-one relationship with the user model, and then we have a post model which actually keeps the post data. We have a one-to-many relationship between the user and post model, and finally we have a tag model and a many-to-many relationship between the tag model and also the post model. So it means that each post can have multiple tags, and at the same time each individual tag can be related with multiple posts here. So yeah, this is a really simple database, and I have hosted this database inside a Neon provider. So this is going to be a Postgres database, and here as you can see we have a db.config file, and inside it we export a factory function. Just set the URL of our database to a env variable inside our env file, and then we just set the type to the Postgres, and then we include all the files that contains .entity and then .ts or .js inside their file name to the entities list here. So this is going to be a type ORM configuration for the Postgres database, and then here inside the main module, our app module, we just configure the config module, and then we are just going to configure the type ORM module with the factory function that we have exported from the db.config file. So this is not going to be a type ORM course or a config module course. We are going to focus on the GraphQL in this video and the next 2 videos. So if you're going to dive deep into the type ORM module or config module, you can watch previous episode of the NestJS full course in my channel. I have separate videos that dive deep into these concepts. So here, as I said, we are going to focus on GraphQL in this tutorial. So if you're ready, let's get into the first step, which is installing the dependencies for configuring the GraphQL module. So for installing the dependencies, I go to the NestJS documentation and go to the GraphQL section, and here I just copied this script for installing the dependencies, and here I open up the terminal and paste the script here. We are going to install 4 packages at nestjs/GraphQL, at nestjs/Apollo, and at Apollo/server, and finally the GraphQL package. All right, it's done, and now we can close this off. So here I am inside the app.module.ts, or root module, and now we are going to configure the GraphQL module. So here inside the import section, let me make it a little bigger. All right, I'm going to put the GraphQL module in the imports list after the type ORM module. So after the type ORM, here we are going to put the GraphQL module and calls the for root function. We need to pass a config object, but before doing that, we need to set the generics here to the Apollo driver config. So Apollo driver config. All right, now I go to the config object, and here first we are going to set the driver, and I'm going to set it to the Apollo driver, which comes from the @nestjs/Apollo. All right, then we are going to set the auto schema to true. So it is actually telling the GraphQL module that we are going to use the code first approach. So as I said in the introduction of this video, we have 2 approaches, code first and schema first. So here we are going to use the code first module, which I think is more straightforward and more developer friendly. So next we are going to set the debug to true. It actually turn on the debug mode in the GraphQL. It is useful during the development because it actually provides more readable error messages in our terminal. And last but not least, we are going to set the playground to true. It enables the GraphQL playground in our browser, which is a in-browser environment for testing and running our queries and mutation of our GraphQL API. It's just like the Postman or Insomnia for testing our GraphQL API queries and mutation. All right, so we're done with the GraphQL module, and now let me run the application. All right, so it gives us an error, and let me scroll up a little bit here. It says that the query root must be provided. So it means that we need to have at least 1 query in our GraphQL schema. So in order to do that, we are going to create a resolver. So what is the resolver? A resolver is just like a controller in the RESTful framework that inside it we just define our HTTP endpoints like get, post, put, and so on. So the resolver is going to be similar to that controller classes in the NestJS, and inside them we are going to define our queries and mutations. So now let me open up our terminal. Let me just close this up. I'm going to create a user module. So NestGMO, I'm going to call it user. Then we are going to create a resolver inside that user module. So NestGResolver, name it user, and -- no spec because we don't want it to create the test file for us. All right, so now let me close this off. Here we have the user module, and inside it we have the user resolver. So here, as you can see in the providers list of the user module, we need to register the user resolver just like a controller or a service. Okay, it's done automatically by the Nest CLI. Now let me get back here. This is our resolver. It's a class just like a controller, but here we need to mark it with the @resolver, which actually make it to be a GraphQL resolver. So here, as you can see, the resolver comes from the NestJS/GraphQL. So inside each resolver, we are going to specify for which entity we are going to create this resolver. Although it is not necessary, but in order to set that, we are going to pass a callback function, and then we are going to pass our entity class. So here, I just return the user, and this way we tell the GraphQL resolver that it is going to be for the user entity. Okay, now here inside the resolver, let's write our first query. So in order to create a query, we are going to use @query decorator. Make sure to import it from the NestJS/GraphQL, and don't confuse it with the query decorator from the NestJS/common. So I just import it from the NestJS/GraphQL, and then here we need to return the shape or type of the returning object of this query. So here we need to pass a callback, which is called a type function, just like the callback that we have passed to the resolver decorator. Here we just pass a callback that actually returns the GraphQL type that this query will finally return to the client. Okay, we just pass the user as the GraphQL type, but the user is just a simple entity class. If I go to it, it's a type ORM class, and we need to tell the GraphQL that this is going to be a GraphQL type as well. We are going to do that in a second, but for now, let me just write our query. So after the query, we need to create a function for that query, and that function will be correspondent to this query. So when we call the query here, we are going to call the function that we are going to write for it. I'm going to create an async function and call it find all. Okay, and here inside the function, we are going to return a empty list of users. So just return an empty list here and just use type assertion to say that it is going to be a list of users. Okay, so here we just didn't specify a name for this query. So in this case, it will get its name directly from its corresponding function. The query name is now find all. So now we can specify a name for this query. I pass an object here and set the name to the users. Okay, now the name of the query is users. Now here, as you can see, we say that the returning type of the query is going to be user type, and this user type should be a GraphQL type. So in order to turn this user class to a GraphQL type, we need to mark it with the @object_type decorator. So use @object_type, which comes from the NestJS/GraphQL. All right, and then we need to mark each of these fields inside the entity class with the field decorator. So here, use @field here, okay, and then inside the field, we are going to specify the GraphQL type of each of these fields. So here, as you can see, the TypeScript type is a number, and we need to pass a type function and return the GraphQL type. It is going to be int, and let me import the @field decorator. Yeah, this is done, and you should not confuse the GraphQL types with the TypeScript types. The TypeScript type for this field is number, but here in the GraphQL type, we don't have the number type. We just set its type to the int type of the GraphQL type. Okay, so here, as you can see, the field, int, and object types comes from the @NestJS/GraphQL. Okay, we're going to do the same for the other decorators. So here, we are going to set @field decorator, and for the string types, we don't need to specify the function type. So just copy this and paste it for the second field, the email. And here we have a profile field that its type is of type profile class. So we need to mark the profile class with the object type. So it is going to be a GraphQL type as well. Okay, so here we are going to put the @field decorator. Okay, and then here inside it, we are going to pass the type function and specify the profile class class here. So as I said, we need also to set the profile class as a GraphQL type. Otherwise, we've got an error. Okay, let's do the same with the post field here. But here, as you can see, the type of the post is a list of posts. So this is the way we define a list of post types in the TypeScript. And this is the way that we just specify a list of GraphQL post types. So here, don't confuse between these two ways. In order to say the GraphQL, it is going to be a list of post type, we need to put the type inside a square bracket. So this is the way for defining a list of post type. Okay, now we need to go to other entity type and mark them with the object type and mark their field with the @field decorator. Okay, so here in the tag, I'm going to use the @object type, and here we need to mark the field with the @field decorator. Okay, let me import the field and int from the NestJS/GraphQL. Okay, let's do the same for the name field. In here, we have a entity type here for the post field. So we need to pass a type function and return a list of posts in the GraphQL way. Okay, so let me save this and go to the profile entity. Again, mark it with the @object type and import it from the NestJS/GraphQL, and then use the @field decorator with all of its fields. Okay, let's import the int class. Let's put the @field on all of these fields. Okay, now here we have a field of type user, so we need to pass the user in the type function. Okay, and finally, let's do the same with the post entity @object type, and then put the field with all of its fields. Okay, do the same with the title, content, and here we have a user field. Okay, we're going to specify the user type inside @field, and here we have a tags, which is going to be a list of tags. So we are going to define it here just like this. We just set it inside a square brackets, indicating that it's going to be a list of tag objects. All right, so now let's open up the terminal. Let's run the application again. Okay, so as you can see, we don't have any error. Now we can go back to our browser and go to the GraphQL playground. So I go to the localhost 3000, which is the address of our dev server, and then /GraphQL. That easy. And as you can see, we have our GraphQL playground, and here we have the schema. So if I open it, you can see the schema is generated based on the entity classes that we have decorated with the object type and object field. You can see we have a profile type, ID, bio, avatar, and user, the tag, post, and also the user. So here, as you can see, for example, in the user type, we have a list of posts, and its type is going to be a list of posts. And these exclamation marks here defines that we cannot return null for this field. And finally, you can see we have a type query, and inside it we have a users query, which returns a user. So now let me go back to our VS Code and go to the user resolver. Here we need to set its returning type to be a list of users. Let's save this, open up our terminal. All right, now let's get back to the browser. Let's refresh the page. Now, if I scroll down here, you can see the returning type of the users query is going to be a list of users objects. So now let me just run the query. Let me close the schema, and here in order to run a query, we just use the query keyword and then a curly braces, and inside that curly braces we are going to call the query. If I hit the control space, I have a nice autocomplete here. I use the users, and here, for example, we are going to select the ID from the users query. So if I run the query, you can see it returns a empty list of the users. That's because here in the project, we just return empty list as the result of this query. So now in the next section of this video, we are going to use type-ORM repository to access to our database and return the data from our database instead of this empty list of users. So if you're ready, let's get into it. But don't forget to like and subscribe to my channel. I have a lot of videos and tutorials about the NestJS and Next.js in my channel, so you can subscribe to my channel for these content. All right, so now let's get into the next section of this video. All right, so let me go to the Neon console where we host our database. As you can see, now we have a post, profile, and tag model, and this is going to be our pivot table, which actually hosts the many-to-many relationship between the post and tag. So here I've already created a seed file and insert some fake data inside this database. So all of these tables now contain some fake or testing data, And now we can use the type ORM repositories to do actually CRUD operation with this database. So let me get back here, and now here let me return the list of users. In order to do that, I'm going to create a service class for this user module. So I open up the terminal. Let me just create another terminal, and here I'm going to use NestJS, which stands for service, and then just call it user and dash dash nospec. So creating the service file, and let me close the terminal. And here we are going to create the method for doing the CRUD operation. So first we need to inject the user repository. So I use the constructor here, and here we are going to use @inject repository from the @nestjs/typeorm, and then specify the name of the entity class is going to be user, and just define private read only user repo and set its type to the repository class. And in the generics, we are going to pass the user entity. All right, now we can use this user repo inside our application here. Let me just fix that user repo. And now we're going to create a find all function, which actually returns a promise that find will resolve to the list of users. And here we just return this.userrepo.find. We need to put await before it because it's a async function. And yeah, this is going to return all the user. So now we just need to get back to the user resolver and inject the user service into this class. Okay, here in the constructor, we're going to use private read only user service and set its type to the user service class that we have just created. Okay, now here, instead of just returning a empty array, we are going to return this that user service that final function that we have just created. So now let me get back to our playground, and first let me just open up the terminal to see if we have any error. Yeah, we have a error, and actually I think we need to register the user repository inside our user module. So let me quickly do that. I go to the user module, and here we're going to put a import list here. So imports, and inside it we are going to use the type ORM module and call the for feature function, and inside it we're going to pass the user repository inside the list. So let me import the type ORM module and also the user entity. Now we have registered the user repository inside our user module, and as you can see, we don't have any error. Okay, our application is running. Let me close this off and get back to the GraphQL playground. And if I run the query again, you can see it returns a list of users. And since we have only selected the ID field, it returns only ID of the user inside the user object. So we can, for example, select the username and also select the email of the user. And here, if I run the query again, you can see inside each user object, we also have a username and email. All right, guys, now let us deal with the nested type in the GraphQL. But before doing that, if you know how we can get rid of these annoying labels here in the GraphQL playground in the Chrome browser, please let me know in the comment section below. But for now, let me just close the playground inside the Chrome and open it inside the Firefox browser. I think those annoying labels does not appear here. So let me go ahead with the Firefox browser here. Okay, so let's get back to our tutorial. Now we're going to select the ID, email, and also the username. And here, as you can see, we have the profile for each user. So here from the profile, we're going to select the bio and also the avatar of the user. So if I run this query, you can see we are getting an error in saying that cannot return null for non-nullable field user.profile. So here, if I open up the schema here, you can see in the type user, the profile is not going to be null. And we have this exclamation mark here, as I said, indicating it's not going to be null. So we're actually returning null for this user.profile. In order to fix that, we need to get back to our VS Code, and let me close the terminal here. Okay, let's get back to the user service, and here inside the user repo.find function, we're going to pass a config object, and then here inside it, we are going to set the relations, and here we need to actually provide the profile, and we're going to set the post here. So here, let me get back to the browser and let me close the schema here. And now if I run the query again, it actually returns without any error. Now we have the email, ID, username, and inside the profile, we have the bio and avatar of the user. But there is a problem here. If we don't need the profile or post of the user, and we want to simply run a simple query just like this. Let me put a curly braces here. Okay. And let's run this simple query that we just want the data inside the user table. We are actually getting a extra data here in the background, which fetching the profile and post of each user, which might be a huge data if a user has a lot of posts inside the post table. So we don't want to do that actually. And in order to deal with this problem, we are going to lazy loading the relations. So we just remove this relations here, and let me just remove the config object. Okay, now let's get back to the user entity here. In order to lazy load these relations, we just need to put them inside a promise. So we're going to pass a promise. It is going to resolve to a list of posts. We are going to do the same with the profile here. Okay, now let's save this, get back to the browser. So if I run the query, it runs as before, but here let me select the profile. From the profile, let's select the bio and, for example, avatar. All right, now let's run the query. As you can see, we have the profile for each user, and inside it we have the bio and avatar. We can do the same with the post of the user. So we can select the post of the user, and from the post, let me just select the title of the post. Let me run the query. Okay, so here, as you can see, for each user, now we have a post list, and inside the post list, we have a post object, including only the title because we only select the title here. Okay, this is more efficient than the way that we use just the relation property inside our find function. We only actually load the relations if we need it. We don't actually load them if we don't select them inside the GraphQL API. So now let me again do it with all of the relations here. So starting from the post, let me put a promise here and wrap the user inside the promise, and also do the same for the tags. Okay, now let's do the same for the user and go to the tags and do the same with the post property here. Okay, let's save this and let's open up the terminal. We don't have any error. Okay, so that's it for leveraging the lazy loading feature of TypeORM for loading the relations on demand. So this is actually a feature of the TypeORM. But for example, if we are going to use another ORM like Prisma, how we can resolve this nested object issue with another ORM like Prisma, or if we are going to use a NoSQL database like MongoDB, how we can resolve these nested object inside the GraphQL. So in order to do that, we can use the resolved field decorator. So here, for example, for the user entity, we have a profile and post relation. So in order to resolve these relation, we are going to get back to our user resolver, and here we are going to use a resolve field decorator, and then here we need to specify the name of the relation, actually the name of the object that we are going to resolve that. For example, let's say we are going to resolve the field profile. That's because here in the user entity we have a field called profile. Okay, let's get back here to the user resolver, and now we are going to create a function for that field. So for example, let's create a get profile function, and here we are going to access to the parent object with the @parent decorator, which comes from the NestJS, and this is going to be a user object. So we're going to type it as user, and then here we can just return the user.profile. So we are using the TypeORM and lazy loading. Let's say we use Prisma here. Actually, in that case, we just need to query our database and get the profiles that their ID is equal to the user.id here. Okay, that easy. Now you can resolve the profile field with any ORM that you are using. So in order to get notice when this function is called, let me log something into the console in this function. So here, let me just instantiate a logger. So private read only logger and set it to new logger class. Okay, and here let's pass the user resolver.name. Then here we're going to use this.logger.debug and say something like fetching profile with user.id in the terminal. All right, so now let me open up the terminal. We've got an error, and that's complaining about the method name. So I think we need to change the name of the corresponding method of the resolve field exactly to the field name. So I just change its name to profile. Okay, let's save this and open up the terminal. All right, the application is running. So let's get back to the playground and run this query. Okay, so we have the user and profile here. Now let's get back to the application, and here, as you can see, for each user we are going to log fetching profile for the user 1, for the user 2, 3. So every time we're going to access the profile field of the user, actually this resolved field function will be called. So for example, if here we're going to just return a profile object just like this, a hard-coded profile object, and let's run the query again. You can see for each of the users we have this actually hard-coded profile. Let me just remove the post here. Okay, so as you can see, this is the hard-coded profile, and also here for all of the user inside of database. So as I said, actually when we call the profile field of the user, we are going to run this function and return whatever this function returns as the profile field for that user. So now let me just put it back as user.profile. Now let's run it again. As you can see, it actually retrieved the profile from the database. So that's it for resolve field and how we can actually resolve the nested objects explicitly in the GraphQL resolvers. So now let me get back to our diagram tool. So we have covered what is the GraphQL and how GraphQL works. We set up the GraphQL, we create our resolver, and here we just resolve the nested object. And now we need to actually create another query for returning just one user based on the ID, and then we are going to go over the mutations. Okay, so let's get back to the VS Code, and now we are going to create another query for returning just one user. So again, add query here. We're going to just return one user. As you can see, the first one returns a list of user, but this one is going to return just one user. And let's name it get user by ID. So get user by ID. We can also remove this name here, and it actually gets its name directly from the corresponding method name. So let me create a function for it, get user, for example, and now we need to get an ID. So in order to get the ID or argument, we're going to use @args_decorator here. And from this actually args_decorator, first we need to specify the name of the field. Now let me just import it from the NestJS/GraphQL. So here in the arguments of the @args_decorator, we need to specify the name for this argument. And then here we can define our parameter in the TypeScript. So now here, this query gets its name from the corresponding method. The name actually will be get user, and it expects an ID. And we can actually explicitly define a type for this argument. We pass a config object, and we're going to define the type here. It is going to be a type functions and return, for example, int type of the GraphQL. Okay, now we can also set the nullable to false. Actually, I think the default value will be false, and if we want this argument be able to take the null values, we can set the nullable to true. So now here we're going to define a function inside the user service. So just return this user service.find one. We didn't declare this method, so let me just declare it quickly and go to the user service and cut it here and paste it at the end of the user service class. Okay, so here we are going to mark it with async, and then we can return with this user repo that find one or fail, and then pass the config object, pass an ID inside it. So it actually find the user based on the provided ID here. Okay, now let's get back to the browser here. Let me create another tab here. So query, and then inside the query, let me make it a little bigger. We're going to call the get user. And as you can see, we need to specify the ID. For example, let me get the user ID 1. And then from that, we are going to select the ID, username, and also let me call the profile. And from the profile, let's access to the bio of the user. So let's run this query. You can see we have the user with the ID 1 and its username. And from the profile, we just got the bio. So if we don't provide the ID here, and if I run the query, you can see it says that the argument ID of type int required, but it's not provided. So we need to actually provide the ID argument for this query. So again, let me put it as 1 and just run the query, and we've got the user. All right, so now let me get back to our diagram tool here. We also covered the queries, and now we are going to create the mutation. But here, before doing that, let me show you how we can improve the readability of our errors with the exception filters. So let me get back to the GraphQL playground. And for example, let's provide the ID argument as 15, which actually we don't have any user with the ID of 15. So let's run this query. As you can see, it says that it could not find any entity of type user matching. And this is the type of error that actually a little messy. So we can use the exception filters and catch this internal server error. And instead of that, we are going to, for example, show the client a not found exception, which is a regular HTTP error. So in order to do that, we are going to use the exception filter of NestJS and GraphQL. So if you're ready, let's get into it. So what is the exception filter in NestJS? So let me show you in a simple diagram here. In NestJS, an exception filter actually lets you to listen for a specific error, catch it, and then handle it in a custom way. For example, in our application, we are going to globally listen for type ORM entity not found exceptions. And when anywhere throughout our application, this type of exception is thrown, we are going to catch it and then handle it in a custom way. So we are going to create a entity not found error filter exception. We're going to listen for this specific exception, type ORM entity not found exception. And in the entity not found error filter, which is an exception filter, we are going to create another exception error, actually a HTTP not found exception, and then return it back to the GraphQL client instead of the original type ORM entity not found exception. That's it. We just globally listen for a specific error and then handle it in a custom way. So let me go back to our project, and here we are going to create a specific custom error for type ORM entity not found exception. So I open up the terminal. You can see we have this entity not found error, which is a type ORM exception. So let me open up new terminal here and use the nest CLI for creating a exception filter. So nest g filter, and then name of the filter, for example, entity not found, and then dash dash no spec because we don't want to create the test file for it. Okay, so here, as you can see, it creates a entity not found here, and inside it we have a class entity not found filter, and we have a catch declarator. So inside the catch declarator, we are going to specify the exact exception error that we are going to watch for. So it is going to be entity not found error of the type ORM. So I put it here, entity not found error, which comes from the type ORM. And then anytime throughout our application this exception occurs, we are going to catch it globally here and then run the catch method here for that exception. So here, as you can see, it should implement the exception filter, which is for a REST API. So since we are using the GraphQL, we need to change it to GQL exception filter, which comes from the NestJS/GraphQL. All right. And then let me just remove this catch function here and let me implement the GQL exception filter. So here in the catch function, let me just remove this error here. And here we can set type of the exception to the entity not found error. So the exception would be our original exception. Now here in the function, we're going to use GQL argument host dot create function and then pass the host parameter to it. It actually converts anything to the GraphQL stuffs. So next we are going to just return a not found exception. So return not found exception, which comes from the NestJS/common, and then say something like entity not found. All right, we need to put a new keyword here. So again, we are going to globally watch for entity not found error throughout our application. And when this type of exception occurs anywhere in our application, we are globally catch it. And then for that, we are going to run this catch function. And this function will return a not found exception, which is a regular not found HTTP error exception. So now let me get back to our GraphQL playground and run this function with this ID, which is not inside our database. Okay, so as you can see, the original error stays in place and we don't actually apply the exception filter. In order to fix that, let's get back to our project. Here, I go to the main.ts file, and here we are going to use app.use global filters and then pass a new entity not found error filter. So we need to import it from the entity not found.filter file that we have just created. Now let's open up the terminal. Okay, the application is running, and let's get back to our GraphQL playground. and let's run the query. As you can see now, this one, the exception is filtered. We have a entity not found error. And if I scroll down here, you can see the status code is 404 and the type of the error is not found, which is a regular HTTP error with the status code 404. So yeah, that's it for how we can actually handling the error with the exception filters when we are using the GraphQL. So now let's get back to our diagram tool and go to the document section. We use the exception filters, and now we are going to cover the mutation. Next, we are going to cover the input types and validations. So let's get into it. But before doing that, don't forget to like this video and subscribe to my channel for more content like this. Your support really matters to me, and I really appreciate your support. Thank you so much. So now let's get into mutations in GraphQL. So I go to our project, and here I go to the user resolver, and now we are going to create a mutation for creating a new user in our database. So I use add mutation here. It comes from the NestJS/GraphQL. We need to specify the return type of this mutation. So it is going to return a user, which is actually the user that is inserted in our database. Now we can also define a name for it, but if we don't, it actually gets its name from the corresponding function. I'm going to name it create user. Okay. And here inside it, we need to get the argument object, which contains all the data about the user that we are going to create. This object is called a GraphQL input type. So it actually is just like a DTO objects when we are using the REST framework, and it just contains the necessary data for creating the user. So here I put an args decorator, and we're going to set a name for that input. We're going to just name it create user input. All right. And then here we can have a argument here, create user input. Okay. And then we need to create that input and set it as a type of this argument. So I go to the user directory here and create a DTO directory. And then inside it, we are going to create a create-user.input.ts. Okay. And inside it, we are going to export a class. I'm going to call it create user input. And then here we need to define the data that we are going to get from the database. So we don't need this password here. So here we just need the username, which is going to be a string, and also email of the user, which is going to be a string as well. But here we're not done yet. Okay, we need to mark it as input type with the input type decorator that comes from the NestJS/GraphQL. And then here we need to use add field decorator with all of these fields inside this class. So since these two are string, we don't need to specify the type function inside the add field decorator. So now we can use it inside our resolver. So get back here and set create user input to the create user input class. As you can see, it is similar to the DTOs when we're going to use the REST API. So now here we're going to just return this user service create function. We haven't declared this function, so let me just quickly declare that and go to the user service class, cut that and paste it at the end of the class. So here let me just mark it with the async, and we're going to say const new user and set it to this user repo.create, and then pass the create user input to it. And then we're going to just return await this user repo.save function, pass the new user to it. All right. So now let me get back to our NestJS GraphQL and let me run this mutation. So mutation, and then here, and let's hit the control space. As you can see, we have a create user, and then we need to pass the create user input. So it is going to be an object. Inside it, we are going to set the name, username actually. For example, we're going to set it to SakuraDev. Okay. And for the email, we are going to put an email inside it, Sakura at, for example, gmail.com. Okay. And from the returning object, we are going to actually specify the ID and the username and also the email. Okay, so let's run this mutation. We have an error, and I think we need to set this email to the email field. Okay, let's run the mutation. As you can see, creating the user was successful. We've got the ID 11, which is the ID of the new user. Now let's get back here to the get user query, and let's call the get user query with the ID 11. We've got an error, and that's because here we didn't set the profile of the user. So let me just remove that, and here let's run the query again. So as you can see, we've got the user with the ID 11, that user that we have just created. Let me just call the post here. It should return empty list. For example, set the ID and title of each post of this new user. Since we don't have any post inside it, it just return a empty list back to the client. All right, so this is for create user mutation. And now let me show you how we can put some validation in the create user input. So here, in order to do validation, let me install the class validator and also the class transformer. Okay, oops, I forgot to put the npm I here. Let's install these two packages. Okay, now let's close the terminal and go to the create user input. Now we can just regularly use the @isString from the class validator, specifying that this is going to be a string and also required. Now we can use the isString decorator with the email and also isEmail decorator. So @isEmail. Okay, let's save this and get back to the GraphQL playground. Let me just remove this @gmail from the email. So this is not a valid email. So let me run the mutation again. As you can see, validation does not work. That's because we need to go to the main.ts file, and here we need to enable the validation. So app.use global pipes and pass a new instance of the validation pipe class to it. Now let me open up the terminal. Okay, the application is running. Now let's run this mutation again. And here we have an error, bad request exception. And if I scroll down here in the messages, it says that email must be an email. Okay, so let's bring back @gmail.com and run the mutation again. As you can see, it does not have any error because we passed the validation pipe successfully. So yeah, that's it for enforcing the validation on our input type in the GraphQL, and it is actually just like the DTO validation. Okay, now let me get back to the diagram tool. We have covered the input types and validations, and now let me just create some mutation for editing and deleting an existing user. So let me get back to the VS Code. Let me close the terminal and let's get back to the user resolver. Let's create another mutation for editing the user. So mutation, again, it returns a user type, and we're going to call the corresponding function update user. Okay, and then it should take a argument, actually two arguments. The first one is going to be ID of the user that we are going to update, and the second one is just a update user input, which contains the data about the field that we are going to update by the user. So we need to create another input type and call it update user input. So here, first let me go to the DTOs directory here inside the user module and create update-user.input, then .ts. Okay, all we need to do is to export a new class. I'm going to call it update user input, and it's going to extend the partial type of the create user input. So use extends here, just like we create a update user DTO, and then we're going to use the partial type, which comes from the NestJS/GraphQL. So make sure that you are importing that partial type from the NestJS/GraphQL, not the partial type that we use with DTO and RESTful API. So here I just pass the create user input, and that's it. We need to just import the create user input, and now every item inside the update user input is going to be optional. Of course, we can add the other fields here. For example, we can put the ID of the user that we are going to update directly inside the update user input, but since we have created a separate argument for this ID, we don't need to do that. So here, let me just mark it with the @input type. Okay, now let's get back here and change the type of the update user input object to the update user input class. Okay, now we need to declare this function inside the user service. So let's declare this update method and go to the user service and cut this method and paste it at the end of the class. So let me remove this exception here and mark this function to be async. Now, first we need to actually retrieve the user that we are going to update from our database. So here I'm going to say const user and set it to await this user repo dot find or fail, pass the ID. We need to put it inside the config object. All right. Then we are going to call the user repository dot save function. So here I'm going to return await this user repository dot save function and pass a new object to this function, a new user object. So put the user class here, and then here in the constructor, if I go to the user class, you can see in the constructor I have already created a partial user class and then use the object that assigned this dot partial. This actually create a user object and set its field with the fields that is provided inside this partial class. So now let me get back here, and here again we're going to use the object that assign and then pass the user here, and then we are going to pass the update user input. So for example, if we provide username inside the update user input, it just set the username of this user with that provided field, for example username, and let the other fields remain as before. So you just update the username field inside the user object, and then we are going to save it inside our database with the save function. So now let me get back to the resolver and save this file, get back to the playground, and let me just, for example, update the user with the ID of 13. So mutation, and then update user. We need to pass the ID. We're going to set the ID to 13, and here we need to provide the update user input, and inside it, for example, let's set only the username to something like my name, for example. Okay, and from the returning object, let me just call the ID and username. Okay, so let's run this mutation. As you can see, the username of the user with the ID 13 is changed to my name, and here let me get this from the get user query. Okay, we can also select the email, and as you can see, the email remained the same as before. We didn't update the email. Get back here and let's update the email to something like my name and at gmail.com. Okay, let's run this mutation. Okay, it's done, and get back here and run the query. As you can see, the email is also updated. So that's it for updating an entity with the GraphQL mutations. And now let me just quickly create a mutation for removing a user. So at mutation, it needs to return a boolean indicating whether the user is deleted or not. And then here we are going to create remove user function. So it should take an ID argument, and its type is going to be int, and then we can get it here in the TypeScript ID and set it to a number. Then in the body of the function, we are going to return this user service remove. We need to declare this method. So let's declare that, get back to the user service and cut that and paste it here at the end of the class. First, let me mark it with async. All right. And then here, let's remove this return. So I'm going to say const result and set it to await this user repository delete and pass the ID to it. And then here we can return if the result affected, which is actually the number of affected records by this delete function. And if it is equals to 1, we can say that we just return true, otherwise we return false. All right, so let's get back to the playground and let me just run this mutation, remove user. Well, we don't have the remove user mutation here, so let's get back here. We need to actually fix this error here. Let's save this. We forgot to put the ending parentheses here. Okay, let's get back here and now hit the control space. Now we can have the remove user. So let me put the ID here and put ID 13, and we don't need to select anything from this remove user. It's just a boolean. So if I run this, it just returns true, indicating that deleting the user was successful. So here, let me get the user with the ID of 13, and it returns an entity not found error. So yeah, that's it, the way we can remove a entity with the GraphQL mutation. And let me get back to the checklist here. We covered the mutation, and finally, we just need to cover the enums in the GraphQL. So let's say that we want to add a role enum in our user entity. So let me get back to our user entity class here, and here we are going to create a role enum for the user. So here, let me create a enum directory here, and inside it, we are going to create role.enum.ts, right? And here I'm going to export an enum. I'm going to call it role, and inside it, for example, let's say we have admin and user. These are two type of the user role, and here we need to register that enum type in our GraphQL. So in order to do that, we are going to use the register enum type function. Okay, it comes from the NestJS/GraphQL, and pass the enum role to it and pass a config object here. We need to set a name for it, and I just go ahead with the role name. Okay, let's save this. And now we can use that role inside GraphQL objects. Here I get back to the user entity, and we are going to have a role field and set its type to the role enum that we have just created. So let me just use the @column decorator from the type rm, pass the config object, and we're going to set its type to enum, and we're going to specify the enum, which is going to be role enum here, and we're going to set a default value to the role.user. Right now we can use the @field decorator and set its type to the role enum in the GraphQL. So make sure that you use the register enum type here and register this role in the GraphQL. Otherwise, if you use this role here in the @field decorator, you've got an error. Okay, so let's save this and let's open up the terminal. Right, so let's close the terminal and go to the create user input, and let's add the role enum here. So I'm going to put role here and set its type to the role enum, and use the @field decorator and pass the enum role type. And also we can use is enum with the class validator and pass the role inside it. Okay, this is for the validation. And now let me get back to the GraphQL endpoint and create user. So if I run this query, it says that we need to provide the role enum. So here in the create user input, let me have the role, and if I hit the control space, you can see we have a nice autocomplete for the value of this role enum type. So let's just set it to admin and run the mutation. Okay, it is created and the ID of the user is 14. Now let's get the user with the ID of 14 and also get its role here. Okay, run the query, and as you can see, the role is admin. So yeah, that's it, the way that we can handle enums in our GraphQL. We just create the enum, and the tip here is that you need to register the enum type with the register enum type function from the NestJS/GraphQL. I think that's it for this video, and in the next video we are going to cover the authentication and authorization in GraphQL, and the next video after that we are going to use advanced TypeScript techniques for GraphQL testing and also paginated queries. Also, as I said, I will upload a full stack blog project with NestJS and NestJS using the GraphQL. So it's a big project. It is going to be more than 6 or 7 hour video in which I'm going to clone a blog project with NestJS in the backend side and NestJS in the front end side, and use the GraphQL for connecting the front end to the backend NestJS. So make sure to subscribe to the channel for the upcoming video, and also don't forget to like this video in order to give me energy to create these tutorials for you. Thanks for your support, and I'll see you in the next video. Bye bye.